Good morning. Here's what I have on the agenda. I wanted to know if you had any Chapter 11 practice homework quiz questions. We need to write the summary for the section of notes that we did on Monday. And we have a new section of notes to talk about today. Also, I wanted to remind you about the Edmodo quiz from Monday's Zoom session. So please take a look at that. Make sure that you do that because it's points I'm going to be putting into Aries. I think there's 9 points, and right now I think the average score is 93. So please do that. And then also please choose your teams for the Chapter 11 homework quiz. I'll be posting that either later tonight or tomorrow, probably tomorrow, and that'll be due on Sunday evening like we did last time. So please let me know about that as soon as you form them. Does that sound good? Do we need to change the agenda in any way? Okay, I guess your silence means it's ratified. So here's the homework quiz. Anything on there felt suspicious, unfamiliar, unexpected? All right, cool. So it seems like we're pretty comfortable with that. So that I'm looking forward to grading those. Sounds like that'll be a lot of happy points. Okay, so next up, we need to write the summary for these notes. So here's somebody. Sorry about that. Okay, so essential question 49. What is the ratio for the length of the legs of an isosceles right triangle? And what is the ratio for the length of the legs of any 30, 60, 90 triangle? And question 50 says, what are the ratios for the legs of right triangles according to the 6 trigonometric functions? And 51 says, how do I solve a right triangle? So here's what we've got. So 49, the ratio of the legs of an isosceles right triangle the ratio is, so we've got 1 over the square root of 2 and 1 over the square root of 2 to 1 when the hypotenuse is 1 unit long. Okay, and the ratio of the legs of any 30, 60, 90 degree triangle are 1/2 to the square root of 3 over 2 to 1. Again, that's when the hypotenuse is 1 unit long. Is that part okay? Somebody else popped up.
Yeah, do you think you could like draw it as a triangle just so we could like visualize it?
Yeah, for sure. So this one, let's see if I can. So that's pretty good. So we'll say this is 45 and 45 and this is 90, right? So if the hypotenuse is one length, right, then this is 1 over the square root of 2, and this side would be 1 over the square root of 2. Does that seem reasonable?
Yes, thank you.
Sure. And then let's see if I can make this happen. Okay. Maybe I am an Android. Okay, so 30 degrees, this would be 1/2. The 60-degree angle will be the square root of 3 over 2. And again, this happens when the hypotenuse is 1. Is that part okay?
What if it's something else?
Okay, so yeah, so that's like what would happen in geometry. So let's say, let's do the 30, 60, 90 because that's just more exciting. So we'll say this is 30 degrees, this is 60 degrees, and this is 90 degrees. And what do you want the hypotenuse to be? Let's go bonkers. 13, right? So what does that mean? So this should be 13 over 2, right? And this should be 13 square root 3 over 2.
So is it just an X? Like
Yeah,
just
you could
put it
totally
in?
think of it like that. Here's the reason why I want the hypotenuse to be 1. I know that by the end of this chapter, we will know the unit circle. And the unit circle is called a unit because the radius is 1. So in our radius is 1 universe, right? That means this side is going to be how long? If this is a 30-degree angle, then this side would be, right? So this side is the same length as this side, right? So this is going to be 1/2. And this side would be the square root of 3 over 2. So if not that I'll be able to, you know what I'm saying, pull that off completely. But that means the x coordinate of this 30-degree angle is the square root of 3 over 2. And the y coordinate will be 1/2. So yes, I'm front loading what they call front loading in academia or in education. I'm front loading this concept that we'll be working with triangles where the hypotenuse is the radius of a circle where the radius is 1. Does that seem sneaky and underhanded?
Kind of.
Yeah.
But like in a good way.
Okay, good. That's reassuring. So that's why we're going with that. Does that make sense?
Yes.
Yeah. So here are the ratios that you would have seen in geometry if that makes you more comfortable. So both of these drawings in the notes that I gave you. Okay, so if we're good with that, then essential question 50. So it wants to know the 6 trig functions. So the 6 trig functions of any right triangle. Everything okay? Okay, so we've got the sine of the angle is the opposite over the hypotenuse. The cosine of the angle is the adjacent over the hypotenuse. And the tangent of the angle is the opposite over the adjacent. So this is the SOHCAHTOA that you learned in geometry, or was introduced to in geometry. Okay, so each of these functions also has a reciprocal. So the sine, the reciprocal of the sine is the cosecant. And it is the hypotenuse over the opposite side. The cosine has the secant. And that's the hypotenuse over the adjacent side. And the tangent, the reciprocal of the tangent is the cotangent, which is the adjacent side over the opposite side. So one of the ways I keep all of these straight, which are the reciprocals, is I know that every pair has a co. So tangent and cotangent. That one's straightforward, right there. Cosine goes with the secant. And the sine goes with the cosecant. Does that part make sense?
Kind of.
Yeah, it takes a little bit of practice.
It feels like the inverse of what we learned.
Yeah.
Okay, cool.
Totally. So this stuff you saw in geometry, I believe that should have occurred.
Yeah.
And then these, they have reciprocal functions. So opposite over hypotenuse, the hypotenuse over the opposite. Yeah, so these come in pairs that are inverses or reciprocal. You want to say reciprocals here. We don't, an inverse thing will happen later in pre-calc.
Oh, okay.
But I've been sworn to secrecy. I can't ruin it for you. You're welcome.
So which is it, cosine and cotangent that are they're like buddies?
No, so the cosine and the secant.
Okay. Oh, okay. I'm done. Sorry.
The tangent and the cotangent.
Yes.
Does that make sense? And then the sine and the cosecant.
All right. I was a little slow to that.
No, it's okay. It's a good question. Okay, so the very last thing is how do I solve a right triangle? So to solve a right triangle, first, draw the picture, draw a picture, draw the triangle. Then, if you're given two sides, use the Pythagorean theorem to find the third. Or if you're given two angles and a side, use the trig functions to find the other legs. Okay, so if you're given two angles on a side, use the trig functions to find the other sides. Oh, and remember that the acute angles of a right triangle are complementary. Okay. Are we okay with that part? So give me a thumbs up if you got that all copied down. Okay, there we go. I think we're mostly okay to go on. All right, so here are the notes that I posted so you could print them out. So we could go over them. So this is the end of 9.1 and the beginning of 9.2. So that happens to be right triangle trigonometry continued and introduction to angles and radian measure. So essential question 52 says, how can you tell when an angle is in standard position? And 53 says, what is a coterminal angle? And what is a non-math analogy for coterminal angles? And 54 says, what is a radian and how do I convert radians to degrees and vice versa? So that's what we're going to be talking about today. So 9.1 example 4, this is the last example I wanted to do from 9.1. So it says, given the specifics of a right triangle below, first draw the triangle, then solve for the missing angle measure and side lengths. So triangle ABE is a right triangle with angle A equals 28 degrees, angle E is 90 degrees, and side B equals 15 units. And so there is my drawing. So I want to solve finding angle B first. So remember that angle A and angle B have to equal 90 degrees because there's 180 degrees in a two-dimensional triangle. So 90 minus the 28 degrees gives me 62 degrees for angle B. Next up, I want to find the side A. And it's the opposite to angle A. So that's making me think about either sine or tangent. And I've been given the adjacent side. So the opposite side compared to the adjacent side is the tangent. So I want to say the tangent of A is equal to A over B. And the tangent, angle A is 28 degrees, B is 15. So I multiply both sides by 15 in order to get A. Does that make sense? I feel like it's kind of jangled up there.
It makes like enough sense.
Okay. So I think I'm gonna just erase this part and let's write it a little bit more clearly because I'm not in love. So let's fix it. Okay, so the tangent of 28 degrees equals A divided by 15. So when I multiply 15 times the tangent of 28 degrees, I get A by itself. Does that make sense?
Yes.
Okay, and so the next thing we need, is calculators out. So I'm going to put this in, and I'm going to round to the 10th place or better. So I've got 15. Now on my calculator, the pi button has a second function of trig. So 15 times second function trig, we're using the tangent. So I hit enter to choose that option, and then 28. Now also notice, I don't know if you can see it, but right up here, it says DEG. So if yours doesn't say DEG, you won't get this number. So let me know, plug that in, see what you get. Let's make sure we're all in the same units on our calculator.
Can you do that one more time?
Sure. Okay, so I've got 15 times the tangent of 28. So 15 times, I hit second and my pi button, which gets me to my trig options. I scroll down to tangent, and then I hit enter to choose that. I put in 28, and then I hit enter again, and I get 7.97 and some stuff. Is that okay?
Thank you. Yeah.
Okay. Anybody not able to find their trig menu? Okay, anybody in the wrong degrees or the wrong units? Okay, all right, seems like we're confident.
Wait, Nima. I can't find the trig option on my calculator.
Okay, so do you want to turn on your screen and show me what calculator you have? It's not one of these in here. Do you have a pi? Where's the pi button on that calculator? Is it on this side or is it on this side? I think it should be with your pi button. Oh, I can't see. Yeah, so is it right there with it? Can you tell me what kind of calculator is it? It's a TI something. What is it? Did you find it? Your microphone's off. You've got like a teeny tiny face right now. I can't lip read.
Sorry, I'm on mute. I can just message you a picture
Yeah, that'd be great.
if you want on Edmodo.
Yeah, or I could also find like there's got to be a Google search that I can like pin.
Okay, yeah. Okay,
That would be- Okay, yeah, so just message it to me and then I'll find it and send it to you. or I'll post it on our webpage because you're probably not the only one that needs it. I know other kiddos have that same calculator.
If it's the TI-30, then there's a tangent button on like the second to the far right column, just like on one of the buttons.
Over here.
Oh, I see that. Yeah,
You got it? Okay,
Okay.
great.
I found that one. Okay. Thank
All
you.
right. I'll still post that resource just so we all have it. All right, great, thanks. Okay. Whew. Dicey. Okay, so what else do we need to find? So we've got one angle here. We found this. We found this side. We need to find the hypotenuse. So I use the cosine of angle A. I'm just going to do this work over here. So I use the cosine of angle A. How am I going to fit this all together? Right here. Does that work? Yes. Okay. So I use the cosine of A equals B, right, over E. Does that make sense? So the cosine, remember, cosine is the adjacent over the hypotenuse. So that's why I've got this adjacent side to the angle and then the hypotenuse here. Does that make sense? Inconclusive. Okay, so I'm going to move forward, and if you have a question, don't hesitate to stop me. So the cosine of angle A, which is 28 degrees, equals 15 over E. And I'm going to treat this as a proportion and cross multiply. I need to get the E by itself. So this gives me E times the cosine of 28 degrees equals 15. And then I need to divide by the cosine of 28 degrees. So that gets E by itself. So 15 divided by the cosine of 28 degrees. So that's what I'm looking for. So again, with my calculator, I've got 15 divided by, can you see this? Yeah, is this on the screen? The cosine of 28 degrees. And that gives me that E is approximately, I'm going to say 17.0 units long, because this 16.98 really pushes that over to 17.0. So I thought we'd just keep our convention of rounding to the tenths place as we would if we were going to be graphing. Is that okay? Okay, so I also left part B blank so that we could try it right now if we're feeling comfortable about that. Does that seem like a good idea?
Yeah.
Yeah. Okay, great. All right, so here's what I've got. Triangle ABE is a right triangle with angle B equals 34 degrees, and angle E is the right angle, and side A equals 13 units. So 9.1 example 4B, here's what I've got. First of all is my drawing. Okay, so I've got something like this. So if I call this A and this B and this E, that makes this side A, side B, and side E. All right, so B they told me is 34 degrees, so I'm going to label that. Angle E is the right angle, and side A is 13. Okay, so there's my drawing. Okay, so now I have to solve the triangle. So the easiest thing to do is to find angle A, and that is complementary with angle B. So 90 degrees minus angle B is 90 degrees minus 34 degrees, which means angle A is, and it feels like summer to me, so these are the types of things where I use a calculator for every little thing, 56 degrees. Is that part okay? Nothing controversial there, nothing unexpected. Okay, now I think this part is kind of, I don't know, it feels trickier to me. So do we want to find side B first? Or side E first? And there's no wrong answer. So let's just go in alphabetical order and we'll find B first. So I've got, from here, I've got the adjacent side and I'm looking for the opposite side. So adjacent and opposite, that's a tangent cotangent situation. So let's say we take the tangent of angle B and we set that equal to the tangent is the opposite over the adjacent side, right? Right, that's the TOA from geometry. Okay, so that's the tangent of 34 degrees equals B is, which is what we're looking for, over 13. Does that part make sense? Okay. All right, so now I multiply both sides by 13 to get the length of side B by itself. And we put this into our calculator. So I've got 13 times the tangent of 34 degrees. And that gets me about 8.8. Is that okay? All right. Then in order to find the hypotenuse, so let's say we've got, how do you want to go about finding the hypotenuse? You want to just use the sine here? Or I'm sorry, the cosine? The cosine?
Yeah.
All right. The cosine of angle B is the adjacent side over the hypotenuse, because adjacent over hypotenuse, that's the definition. That's the ca part of geometry. So this is the cosine of 34 degrees equals 13 over E. And if I make, do you want the proportion or do you want the shortcut?
Could you tell us the shortcut?
Yeah, the shortcut is I can just switch these. So E equals 13 over the cosine of 34 degrees.
Would you just multiply the cosine of 34 degrees to both sides?
No, so I would multiply by E and then divide by the cosine of 34, and that's how I would get to here.
Oh, because oh, never mind.
Yeah, because we want to get E by itself. So in my calculator, I've got 13 divided by the cosine of 34, and that gives me that side E is approximately 15.7 units long. Whether they're feet or gummy bears, unicorns, doesn't matter. So that's our triangle. Does that make sense? Okay. All right, so hopefully that makes sense and you're good with it, or you'll tell me soon. So here's the definition we need for this example. So in a plane, in a coordinate plane, an angle can be formed by fixing one ray of it, called the initial side, and rotating the other ray, called the terminal side, about the vertex. So here's my drawing. So this is the initial side, is on the positive x-axis. That's important. And then when we're counting angles, we count counterclockwise. So this is the terminal side. So this is about, I don't know, 120 degrees or so, 130. An angle is in standard position when its vertex is at the origin, so right there, and its initial side is on the positive x-axis. So that's what we are going for. So in 9.2, example 1, we have to draw an angle in standard position with the given angle measures. So I did part A for you, and I thought we would do B and C together. So they want us to do 240 degrees. So keep in mind, this is a right angle. So that's 90. This is another 90. But a third 90 would be 270. So that's too far. So we need to back up like 30 degrees. So, or a third of the way, right? So this is my 240 degree angle. Again, we count in the counterclockwise direction from the positive x-axis. Is that okay? All right, so we're ready for part B. Okay, so we have to graph the 500 degree angle. So here we go. All right, so there's 4 right angles, so that means 4 times 90 is 360 degrees. So I know where, if this is our initial side right here, we're already gonna go 1 full time around, right? But how much farther around do we need to go? Do you know that off the top of your head? Yeah, me neither. So I say 500 minus 1 full revolution gives us 140 degrees. Okay, great. So we go 1 full time around, and then 140 is about 50 degrees more than 90. So this is the first quadrant, gives me 90. And then halfway would be 45 degrees, so it's just a hair past the halfway point. And since I'm not using a protractor, we're gonna say that's our 500 degree angle. And again, this would be the terminal side over here. Whoops. Ish. Does that make sense? Great. Seems like you're taking this like a fish to water. Okay, so 9.2 example 1C, we have to draw negative 50 degrees. Now that means we're counting in the clockwise direction from the positive x-axis. So like I said, this would be 90 degrees here. So 50 is just a little bit past the halfway. So something like that. So if this is the initial side, so this is our initial side, and we're counting this way to the terminal side. So this would be negative 50 degrees. Anything crazy or unexpected happening there? Okay, great. All right, so the next thing I wanted to tell you is this definition here. So if 2 angles have the same terminal side, then they differ by 360 degrees, and they're called coterminal angles. So that feels like kind of a crazy definition. I tend to think of, so my non-math analogy is, you know, when you meet somebody and they have the same birthday as you, but they're either older or younger? Like if you think of the calendar as being a whole cycle, you know, because it's 1 revolution around the sun, so technically it is, then someone who's older than you would be backwards because they did more rotations than you did, and someone younger than you would be forwards because you've done more rotations than they have. Or maybe that's vice versa. I'll have to think about that some more.
That makes sense.
Good, because that's what we got to do here. So and this is 9.2 example 2, they want us to find 1 positive angle and 1 negative angle that are coterminal. So this first thing they've given us is negative 45 degrees. So my drawing is kind of crazy, so I'm going to draw it again for you. so you can see it in real time. So negative 45 degrees is like just this halfway, right? So this is negative 45. So a coterminal angle would be, this would be like our positive one, right? So that happens to be 360 minus 45 degrees, which is 315 degrees. So this one's 315 degrees. And what if we went around a whole nother time? Right? So what if we went, let's try this again. So this is our 45 here, negative 45. And what if we went a whole time around and then back to this angle? So that would be negative 360 minus 45, right? But because they're both negative, we're really adding. You remember that rule? So that gives us negative 405 degrees. Does that make sense?
Yeah.
Okay, super. So how do we feel about part B? Are we ready for that? So 9.2 example 2B. So we've got 395 degrees. So this angle is about what, 360, 35 degrees past. So something right around here. So this is our original angle. This is 395 degrees. So we can see that one angle would be 35 degrees. And another angle going the other way would be 360 minus 395, minus 35. How do we want to think about that, Kings? Yeah, minus 35.
So are you subtracting the difference?
Yeah, it's weird, right? This is why I feel like you have to draw a picture. Otherwise it's,
Yeah.
it's, so this angle going this way would be negative 325 degrees. Does that make sense? So this would be our positive angle, and this would be our negative angle. But keep in mind, there are multiple answers because you could just keep going around and around and around. Does that make sense?
Yeah, it's like I mean, it kind of looks like the axes on like a graph that we have normally used. Like the right side is positive and the left side is negative. Is that wrong?
Hang on just a
The
second.
way you think about it?
Oh. Nice. Okay. I don't. Okay, say that again, Charlotte.
It just kind of looks like what we've been doing in class where like like the right side is positive 35 and the left side is like negative. I don't know. That's just like a way you can think about it, I guess.
Yes.
Okay,
Yeah, that
cool.
works.
Wait, Miss Nemeth.
Yeah.
So the negative 325 angle is the 360 minus 35.
Yes.
Okay.
Yeah. So this one this is our negative angle, and then this was our positive angle, which was just like, because it goes around more than once, so we just kind of took this little wedge.
I get that part. I'm just confused on the part where it's 360 minus 35. Is
Okay.
it like it equals negative 325?
Yes. Oh, I see what you're saying. Yes. Okay. So, all right, let's try this again because that doesn't make sense. You're right. Okay. So if we have 360 degrees minus 395, that's what gave us. So if we go around one time and then we back up 395, that will give us an angle down here. So that's not what we want. How do we actually think about this? That is a great question. Why do I just take that for granted? So 360 minus 35. So if we say 360 degrees minus 35, that does get us 325 degrees. Everybody's okay with that part, right? But 325 degrees is going to be over here. That won't be coterminal. Ah, okay, so what we want to, but that still doesn't give us, no, that still doesn't do it. Well, and this too would give us like negative 35, right? So that's that point over here. This is why students don't like this. Because I don't know, I'll have to look and see what Ron says. I'm sure he has some multiple equation way of figuring this out. But I just know that when I start here and I call this 360, when I'm going this way, I know whatever angle I get will be negative.
Mm-hmm.
Because I'm going in reverse.
Right.
Right? But yeah, I am going to get a better answer for this than what I have right now. Because
Okay.
that's annoying. So I'm gonna put that right there so I don't forget. Okay, so the very last thing that we need to do is, so 1 radian is the measure of an angle in standard position whose terminal side intercepts an arc the same length as the radius. So a radian is another angle measure. So we've been using degrees like our whole lives, and radians are actually more precise. So if I have this angle, like let's say I've got this circle, right? So this is the length of the radius. And so when this arc is the same length as the radius, then this angle is 1 radian. That's why in a circle, the circumference is 2 pi radians. Because in the circle, this would be 1 pi and this would be 2 pi. Does that make sense? I can see you're overjoyed about this. Okay, so we'll do a little bit more straightforward math here. So when we're converting between degrees and radians, if you have degrees and you want it to radians, then you start with your number with degrees here, and you've got pi radians over 180 degrees. And so the degrees of this number and the degrees in the denominator cancel out, and you're left with radians. If you have radians and then you multiply it by 180 degrees over pi radians, and the radians here and the radians here cancel out, and you're left in degrees. Does that part make sense from chemistry and conversion factors?
Yeah.
Okay, super. So in 9.2 example 3, we've got an angle, and I want you to draw them, and then we have to convert them to the other unit. So here I'm given 120 degrees, which I know is 30 degrees past the first quadrant. And so my conversion factor here is 120 degrees times pi radians over 180. Remember, I want to cancel out the degrees, so it's got to be in the denominator. And so 120 over 180 is the same as 2 over 3 times pi radians. Is that okay?
Sorry, could you repeat that?
Yeah, so So pi radians is the same as 180 degrees, right? Because this is half a circle and this is half a circle. So I can multiply by 1 whenever I want to. So if I have 120 degrees and I want that to be in radians, the only thing I can do is multiply by 1. And so I've got pi radians over 180 degrees because I want the degrees in the numerator to cancel with the degrees in the denominator. So 120 is like 2 60s and 180 is 3 60s. Does that make sense? So 120 divided by 180 is the same as 2 over 3 when I simplify the factor of 60 out. So I get 2 pi over 3 radians. Does that make sense?
Yes.
Okay, great. Then the very last example, we've got negative pi here. So when I draw my angle, it's going to be this is negative pi. And if I want to turn that into radians or into degrees, then the pi cancels with the pi radians and I'm left with negative 180 degrees. Does that make sense? Oops. Is that all right? Okay, well, we're pretty much out of time. So if you have math questions, you should either tell me now or message me later on Edmodo or email me. And other than that, I will see you on Wednesday. Please don't forget the Edmodo quiz that ends tonight at midnight. So please do that so you get those happy points and we can put them in Aries. And also your teams for the Chapter 11 homework quiz. Message me those things, please. Other than that, I will see you on Friday.
Thank you.
Thank you.
Thank you.
Thank you.
Miss Neem.
Yeah, what's up?
Thank you.
You're welcome. Take it easy.